Hi everybody, today we're going to continue with the chapter 6 arithmetic series and geometry series. So we will look at the subtopic of 6.2 geometry series. So before we start our lesson, let's see the learning outcomes. At the end of the lesson, the student should be able to A. Identify the geometry series, B. Determine the nth term of a series of Dn equal to ARn minus 1, C. Use the sum formula of Sn equal to A 1 minus Rn over 1 minus R for R less than 1, or Sn equal to ARn minus 1 over R minus 1 for R greater than 1. And last one is S infinity equal to A over 1 minus R for the modulus R less than 1. So let's see the geometry series. A geometry sequence is a sequence in which the ratio of any two consecutive terms is a constant. Generally, the term of an geometry sequence is given by A, AR, AR squared, AR cubed, and etc. Thus, the nth term, the n for the geometry series is given by AR to the power of n minus 1, where A is the first term and the R is the common ratio. So let's see the example 1. Determine whether 1, 3, 9, 27 is an geometry sequence or not. Let's see the solution. So we have the 1, 3, 9, 27, and let us assume that the 1 as the first term T1, 3 is the second term T2, 9 as the third term T3, and 27 as the fourth term T4. So what shall we do is we try to find the T2 over T1, which is 3 over 1 is equal to 3. Then we have the second set of T3 over T2 is 9 over 3 is equal to 3. And the last one is the T4 over T3 is equal to 27 over 9, which is also equal to 3. So from the answer of the three set that we have get, so we can make a conclusion that T2 over T1 is equal to T3 over T2 and T4 equal to T3, which is equal to 3. So which means that this is a geometry series. So let's see the example 2. Write down the next two terms of the series of 1, 1 over 3, 1 over 9, and 27. And we move on to the solution here. The question mentioned here is next two term. So next two term here means that the term of number 5 and term number 6 after the term number 4 of 27. So here we determine the T5 and T6. Before that, what we do is we need to determine the first term A, which is equal to 1, and also the R value, common ratio, which is taking 1 over 3 over 1 is equal to 1 over 3. So next we will apply the formula of Tn equal to ARn minus 1 to find T5 and T6. So from here we substitute the value of n equal to 5, the A and the R. So what we will get here is the 1 over 3 to the power of 4, and we will get the answer is 1 over 81. And the next one is the term number 6. So term number 6 also did the same things. We substitute them, and finally we will get the answer is 1 over 243. So let us move on to the sum of the first n term Sn of the geometry sequence, which is given by the formula of Sn equal to A times 1 minus Rn over 1 minus R for the R less than 1, or is equal to ARn minus 1 over R minus 1 for R greater than 1. So let's move to example 3. Find the sum to the 8th term of the geometry series for 2 minus 6 plus 18 minus 54 plus. So let's see the solution. we get the a first, which is equal to 2, and next is the r, which is negative 6 over 2, and we will get negative 3. So here we're going to apply the formula of the Sn, which is equal to a1 minus rn over 1 minus r, and by substitute the a and the r inside with the value of the 8, so we will get the answer is 1 over 2 times 1 minus 3 to the power of 8, that is equal to negative 3280. So let's see. The sum to infinity of a geometric series is given by S infinity. So S infinity is equal to a over 1 minus r for the modulus r less than 1. So the next one we will look at is the example 4. Find the sum to infinity of the following series. For 1 plus 1 over 4 plus 1 over 16 plus. So the working will be, so first of all, we're going to find the a, first term, which is equal to 1, and r is the 1 over 4 over 1, which is also equal to 1 over 4. Then we will apply the formula of S infinity, which is equal to a over 1 minus r. By substitute the a and the r into the formula, so we will get 1 over 1 minus 1 over 4. So finally we will get 4 over 3. So that's all for today. Thank you.